Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the TEAS. We have been solving math problems out of this book here, the study manual for the TEAS. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 309. Please turn to it. Page number 309, and today is our lesson number 80. The very last day today we're going to meet. We begin our journey on day number 1, which was August 23rd of 2013, and today is a Thursday, September the 26th. September the 26th. It has taken us a little over a month to finish our journey from day 1 through day 80th. Let's begin, shall we? Number 24. It says the local store, the local shoe store that is having a buy one pair of shoes and get the second pair of equal or lesser value for half off, for half the price. So here's the deal. You buy one and you get one free. Or not get one, get the second one at 50%. Get second one at 50%. And of course, when they say second one, then they're talking about the cheaper one, obviously. I know it's a cheaper one because I learned it the hard way. Because I saw this ad one time where you could buy one and you get the second one for 50% off. And you know, being the bride that I am, I went to the store and I proudly picked up the largest flat screen television that they had and a piece of chewing gum. I was hoping to pay 50% off the price of the television. It didn't work that way. The 50% off is the cheaper one. Do you understand? The first one is $79.95, and the second one, the cheaper one that we're buying, is $54.95. And we're going to get half off this price, the cheaper one. Now, key here, as always, we've been at it for 80 some days now. The key here, and so we know by now, the key here always is to try to save your time by rounding things up or down, by rounding things. That's what we're going to do here. Don't try to figure out half of 54.95. Nobody's going to give you extra credit for it. Do you understand? Just make that into 55. Make that into 55. Oh, what the hell? I'm going to make it into 50. Watch what happens. I'm going to make it into 50. And this is 80. And half of 50 is 25. So 80 plus 25 is $105. Now pick the one answer choice that comes closest to $105. That's it. Don't have to waste your time. The answer choices, the way they're laid out, obviously it's not going to be $95 because we're looking for something that's close to $105. When you're doing this thing, it's okay as long as you know, as long as you're cognizant of the fact that you are overestimating or underestimating. You must always know what you're doing here. Here, by pretending that $54.95 is 50, we are slightly underestimating it. We actually are underestimating it about $2.50 because we left out $5 and half of $5 would have been $2.50. So we could have very easily done 27.5. But anyway, the actual amount is slightly over 105. Can you find one amount that is slightly over 105? Obviously, it's not going to be $135, which is answer choice D. Answer is, of course, C. The answer is C. Or if you want it, as I just said, instead of rounding it to 50 and being so lazy, we could have done 55 and figured out how it is half of 55. And of course, we know how to figure out half of 55. Divide 55 by 2. Let's do it together, shall we? How many 2's in a 5? 5 has 2 2's. 2 2's are 4. 2 2's are 4. 2 2's are 4. And of course, by now, you should know the language that I use because today is our last day. This is what I'm trying to tell you. 2 2's are 4. 2 2's are 4. What happens to the remaining one? Because this was a 5. What happens to the remaining one? The remaining one goes and joins the 5 and becomes 15. How many 2's in a 15? 15 has 7 2's. 7 2's are 14. 7 2's are 14. And of course, we still have a remaining one there, don't we? And that remaining one is the one that is being divided by 2. So it's 27.5. So if you wanted to, we could actually done a little bit more precise job, little bit of a thorough job. by adding 27.5 to it, and in which case we would have gotten the answer of 107.5. 107.5, and of course the answer is C. Let's move on, shall we? Number 25. So here, when we had 15, what I'm saying is that, what I said was, 7 2s are 14. 7 2s, not 2 2s. Not 2 2s, but 7 2s are 14. That's what we said. And the remaining one is this right here being divided by 2. Let's do the next problem. Number 25, which is a simple linear equation. We just have to find the value of x, nothing to it. 25, we're told that x times, or 2 times x plus 1 equals 3x minus 1. We just have to open the parenthesis and off we go. So 2 times x is going to be 2x, and 2 times 1 is going to be 2 plus 3x minus 1. Now watch what happens. Watch what happens. Typically we bring all the unknown to the left hand side and all the known quantity to the right hand side. Today we're going to violate that rule. We're going to violate that rule because if we were to bring 3x to this side, by the time the 3x comes over here, it's going to be negative 3x, and we get a positive 2x. We're going to end up with a negative x. I don't like dealing with negative x. Let's bring the 2x to that side. In other words, when we say let's bring 2x to the right hand side, or let's bring 2x to the other side, doesn't have to be right hand or left hand, it could be any side. When someone says let's bring 2x to the other side, that's just a grown-up way of saying let's subtract 2x from both sides of the equation. Let's subtract 2x. Let's subtract, this is a positive 2x, let's subtract 2x from both sides of the equation. Well, we have brought the 2x on this side. I'm going to rewrite this thing because I need the room here. I'm going to equals 3x minus 1, and here's our 2x. And this 3x has a positive sign in front of it. And now, so the 2x is already here. Let's bring the 1 to this side. How do we bring that 1 to this side? When we say let's bring 1 to the other side, that's another way of saying is that let's add 1. The grown-up method was simply said, let's bring 1 to the other side. What we're actually saying is we want to add 1 to both sides of the equation. Let's add 1 to this side of the equation and that side of the equation. That's it, we're done. So positive 2x and negative 2x will cancel out. Of course, that was the whole point. And here we have 3 plus 1, which 2 plus 1, which is 3. And here we have 3x minus 2x. 3x minus 2x is x. And negative 1 and positive 1 will cancel out. Of course, that was the whole bloody point. There you go, we're done. X equals 3. X equals 3. All we have to do now is to put this value back in there in the original equation to make sure that it works, which is what we're going to do. Let's put it back in the equation to make sure that it works, shall we? So we have 2 times x plus 1, and x we just found out to be 3, so it's 3 plus 1. 3 plus 1 equals, and how much is 2 times 3 plus 1? 3 plus 1 is 4, so it is 2 times 4, which is 8. Let's see what we get here. Here we get 3 times x, which is 3, 3 times x, which is 3, minus 1, and 3 times 3 is 9, 9 minus 1 is 8. What do you know? It checks out. 2 times 4 does equal 8. It checks out. It's the correct answer. Let's move on to the next one, shall we? Number 26. Just give me 1 second. Number 26. In number 26, we are told that the fisherman wants to present his yearly catch totals in terms of the number and the type. Total yearly catch in terms of number and type. All of this is important in terms of number and type. This is very important. You will see that in a second why that word is important. And the question simply is, which of the 4 choices that are given to us, which of these 4 pictorial way would be appropriate? Would line graph be appropriate? Line graph will not be appropriate. In the line graph, we show total catches for different years. In here we would have had years, and here we would have had the catch. There are 2 problems with line graph. There will be 2 problems here with line graph. One is that on the y-axis we will be presenting the total catches. We don't want to present the total catch. We want to present the total catch in terms of time. And line graph will not show you by the type, it will show the total catch for different years. Different years. We do not have years, we just have 1 year. This fisherman wants to show his catch for this particular year or last year or whichever year that we're talking about. For that particular year, he wants to show his catch, total catch in terms of different types. Line graph will not be appropriate. Line graph will not be appropriate. Let's move on. Pie chart. Can you tell me why pie chart is not appropriate? Of course, we could present in the pie chart which we can show a different type of catch, different type of catches, type A, type B, type C, type E, and so forth. In the pie chart, these are different type of fish. A, B, C, D are the different type of fish. Do you understand? So this is a different type of catch. Why can't I show this? And this is my yearly catch. Why can't I use the pie chart? Can you tell me? Pause the video if you have to. Pause. It will be a good exercise, and put your thinking above. Tell me why pie chart would not be appropriate. Pie chart presents percentages. These are percentages. These are all percentages, and all of that together has to add up to 100%. The circle represents 100%. Pie chart, we could actually depict the different type of fish that we caught this year, but it will be presenting it in terms of percentages. This guy doesn't want to show the percentages, he wants to show the absolute number. Hence the emphasis on number and type. Not the percentage and type, but number and type. Pie chart would not work. Pie chart would not work. There we go. Pie chart will not work. The third choice that they give us is scatter plot. A scatter plot is not going to do anything. What we need here is the bar graph. Bar graph, the scatter plot is not going to do anything. What we need is a bar graph, which is going to look like this. Here we'll have the number of catches, and here we'll have the type of fish. Type of fish, and we will have different bar graphs. And so on and so forth. Here's our type A, type B, type C, type D, and type E. Different types of fish that we caught that particular year, whichever year it happens to be, but it is for 1 year. And these are the numbers. It tells you how many fish of type A did we catch, how many fish of type B did we catch, how many fish of type C did we caught, and so on and so forth. So what we need here is a bar graph. What we need is a bar graph. Let's move on, shall we? Number 27. Number 27. In number 27, we're being asked to multiply two decimals here. 0.013 times 0.04, and we have done this thing many a times in the previous videos, day 1 through 60. We have come across many problems where we had to multiply the two decimals, and we know what to do. We simply take the numbers, pay no attention to the decimal, just take your 13, and multiply it by 4. 13 times 4 is, 3 times 4 is 12, carry 1, and 4 ones are 4, plus 1 is 5. You see what I just said? 4 ones are 4. 4 ones are 4. That's how we speak where I come from. 4 ones are 4. So you see, 4 ones are 4. 4 ones are 4 plus 1 makes you 5, gives you 5. So 52 is the answer. 52 is the answer, and now we worry about our decimal. And how do we worry about our decimal? Well, just by simply counting. Just by simply counting, see where the decimal place appears. In this guy, there are 3 places, 1, 2, 3. And here there are 2 places, 1 and 2. 2 plus 3 is 5. So here the decimal exists here, it's 52.0 here. We have to move this decimal place by 5 places, 1, 2, 3, 4, 5. It's going to end up here. We need 3 zeros. Voila, we need 3 zeros, and it becomes this decimal here moves here, 00052. There is our answer, 00052, and that would be answer choice A. Answer choice A. Let's move on then. The next one, number 28. Number 28. we are told that one number y is 3 more than half the other number x. That's right, shall we? How do we translate this sentence in English language into a sentence in mathematical language, in the sentence of algebraic language? In the language of algebra, a sentence, a comparable term for a sentence in algebra, in math, is an equation. An equation is a sentence. We have to translate this sentence into a sentence of the language of mathematics. Let's do it, shall we? Y, there is your y, how do we translate is? Is simply means equals. Y is half of another number. Half, what does of mean? Half the other number, half of the other number, half of another number. Of means times. Half of another number. Of means times. Of means times. Another number which they are calling x. Now what does this sentence say? This sentence says that, okay, listen carefully. This sentence says y is half of another number. Well, we left out this part. Y is not half of another number, it's 3 more than that quantity. Whatever this quantity happens to be, this y is actually 3 more than that. This is not enough. This quantity actually is 3 less than y. Y happens to be 3 more. More means plus. 3 more than what? Half of the other quantity. Half of the other quantity is this. Now we have to add 3 more to it. Voilà, there you go. That is the answer. And that will be answer choice. And of course I wrote it like this, half times x. We can write that as y equals 1/2 x plus 3. 1/2 x plus 3. Because we don't have to write down the times like this. We could have another way to write it is like this way. And you can see that answer choice would be answer choice B. Answer choice B. If we leave out this 3 part, then what it says is that y is half of x. Some number y is half of some other number which we're calling x. That's not the case. This guy is actually 3 more than this quantity, so we have to add 3. That's all. Let's go on to the next page. Let's finish it up. There's only 2 more left on the next page. The penultimate problem, number 29. And that will be page number 310. Oh boy. Alright. A graduating class of nurses is planning a one-day workshop. Alright, good for them. 125 of them have registered so far. Each nurse will receive a notebook, pen, logo bag and a flash drive. Oh, yippee. The supply company charges $25 for the notebook, alright. So each of them will get, each gets a notebook, which we are told is $75. A pen, which we are told is $25, if I'm not mistaken. Yep, $25 of pen, $3.25 for the bags. We have bags for $3.25. And then finally we have flash drives for $5.85. $5.85 for the flash drives. Let's first find out what the total cost is for one nurse, and then we'll worry about finding out the cost for all the nurses, and we are told that there are 125 of them. Alright, one thing at a time. Let's find out what's the total cost of all these items is. What's the total cost of all of these items is. Yes, it should be is because we're talking about the cost. Cost is, you see, cost is singular. Let's find out what the total cost of all of these items is, and once we have the total cost for one person, we'll multiply it by the number of people that we have there, which is 125. Let's find out, shall we? Again, it's okay to approximate. It's not only okay to approximate, it is highly recommended. That's what you should do. Because if you sit there and start adding up all the nickels and dimes and pennies, it will drive you bonkers. Don't do that. It'll be a waste of time. Sheer waste of time. Okay? 75 plus 25 is $1. Alright, so 75 plus 25 is $1. And I'm going to pretend that 25 and 85 is another $1. We're going to be off by 10 cents. Okay? Had this 85 been 75, then it would have been exact. 25 plus 75 would have been another $1. So we're going to be off by 10 cents. We're going to be underestimating it by 10 cents. It's okay to estimate as long as you're cognizant of the fact that you're underestimating or overestimating. Here we'll be underestimating by just a dime, 10 cents, which is not a big deal. 1 plus 1 is 2, 2 plus 3 is 5, 5 plus 5 is 10, 10 and then another $1 and another $1. So it's $12. $12 per nurse. Now we just have to do 125 times 12. 125 times 12, you have two choices. You can either do it out, which should not take that long. We can just do it out, or we can do some quick and dirty way. Let's do it out. It's actually not that bad. Okay, listen carefully. 12 fives are, again, this is what I'm saying. 12 fives. 12 fives are, how much are 12 fives? You should know your tables. 12 fives are 60. And how do I know 12 fives are 60? I just told you that you should know your tables. I was in fact lying. How do I know 12 fives are 60? I don't. I do know 12 tens are 120. If you multiply 12 by 10, then I know it's 120 because all you do is stick a 0. Becomes 120. And then you just take a half of that. So if 12 tens are 120, then 12 fives must be 60. That's all. That's all. So 12 fives are 60. That gives us 0, carry 6. I'm multiplying by 12, not by 2. Do you understand? 12 twos, 12 times 2. 12 times 2 is 24. 24 plus 6 is 30. That's another 0, carry 3. 12 ones are 12, plus the 3 is 15. There you go, that's your answer. Pick the answer choice that comes closest to it. 1500 is what we're looking for. Now as you look at the answer choices, at that point you will decide whether or not what you approximated here was okay. If the answers are too far apart, you can get away with it. If the answers are not too far apart, if the answers are too close to each other, then you have to go back and do the refinement. The adjustment, as I call it. Do you understand? Here, as you look at the answer choices, they are in fact very close to each other. I don't like it. We came up with $1,500 even. It's making me nervous. I want to do a little refinement. Do you understand? Don't pick A. Don't pick A just because it's there. Because A, it just says $1.40, and I know we are more than $1.40 off. Listen carefully. Listen very carefully. Do you remember how much off we were? We were off by 10 cents right here. 25 cents and 85 cents. Had this been 75, as I said in the beginning, had this been 75 and 25 would have been another $1. We are off by 10 cents, as I told you before, as I made the remark. We are off by a dime. Question is, how many dimes are we off by? The answer to that is, we are off by 125 dimes because there are 125 nurses, and for each of the nurses we counted 10 cents less than what we should have. We are off by 125 dimes. Can you tell me how much money is 125 dimes? How much is that? If you have 125 dimes, 10 dimes we know make $1. 125 dimes is very simple. All you have to do is move the decimal place to here. It'd be $12.50. 125 dimes, that's $12.50. That's what I'm going to do here. I'm going to add $12.50. And now the calculation is precise. It's 5, 2, 1, 5, 1. $1,512.50. And that's your answer choice B. But we knew it was not answer choice A because answer choice A is off by only $1.40. As I always remind you, it's okay to approximate as long as you're fully cognizant of two things. First of all, you have to always know whether you're underestimating or overestimating. And you must have a decent idea as to how much you're overestimating or underestimating. Are you off by 3 pennies for each person? Are you off by $1 for each person? Are you off by 10 cents for each person? Because it plays a role. Had we been off by $1 for one person, the fact that we have 125 people, our final answer would have been off by $125. On the other hand, had we been off by only 2 cents, it's not a big deal, because 2 cents, we are 125 people, we are off by 250 cents, it's $2.50, that's all. And if you have to do that adjustment at the end, go ahead and do it. In most cases, you don't have to do the adjustment, because in vast majority of the cases, the answer choices are too far apart from each other. Here, that was not the case. So we do the adjustment, that's all. Enough of the talk, let's do the very last problem so we can get it, so we can move on. We need to erase this thing, obviously. Oh, I should have given you a chance to actually copy it down in case you wanted to. Alright, what I'm going to show you very quickly now is how to multiply 12 times 125 if you had to, without actually another method, that is. Here we multiplied 125 by 12 like we did here, we multiplied by 12. Another way would have been this. 125 times 12 is what we're trying to figure out. Another way would have been this. We know 125 times 10 is 1250. I'm taking up too much room here, it's getting too crowded. Let me redo it. 125 times 12 is what we're trying to figure out. We know 125 times 10 is 125 is a 0 at the end. This represents 10 125. We have to add 2 more 125s. We have to add 2 more 125s. And how much is 2 125s? 2 125s would be 250. There you go, you add them up and you get the answer. 5 plus 5 is 0. Carry 1. 1 plus 2 is 5. And then here's your 1, 1500. We get the same answer as this guy. So that was another way of figuring it out. How much is 12 times 125? When you have to multiply something by 12, what I'm trying to make you understand here is that when you have to multiply something by 12, another way, if you want to cheat, is to simply multiply it by 10, which is very easy. Just stick a 0, and then take the quantity and multiply it by 2, and just add up the two numbers. Let's do the very last one, shall we? We've been talking too long. Let's do the very last one. What does it say? A young couple is buying their first home. Oh boy. Okay, all right, if you say so. A young couple is buying their first something. This is the second time. I just noticed it. I did not notice it before, I swear to God. This is the second time it's been hurting. I'm going to point out something here. And if I can find the page number very quickly in the English portion where they talk about the antecedent, the agreement of antecedent and the verb. I will find it very quickly if you just give me a second, because last time we made a fuss about it. Subject verb agreement. There you go, pronoun antecedent agreement on page 180. On page 180, they talk about pronoun and antecedent agreement. A pronoun must agree with what follows before. A couple, that's why it's a couple. A couple is singular. A singular couple cannot buy their first something. It is wrong. The grammar is wrong. Anyway, enough of the talk. Let's do the problem. So they're buying, the couple is buying its first. I'm not sure what gender would you assign to a couple. I think it would just be it. It obviously cannot. It will be it. It would have to be, because obviously it's not theirs. It's there. It would be because the couple is singular, as far as I know. Anyway, back to our problem. This is taking too long. I don't know why I digress like that for no good reason. A couple is buying its first home for $183,000. A contractor gave them, all right, so they're buying a home. The home, we are told, A home, we are told, is 183,500. It happened one more time. The same exact thing happened one more time before, and it ticked the hell out of me. I don't remember where it was, but it did happen before. A contractor gave them a $12,335 bid for the renovation. $12,335 for the renovation. What is the question asking actually? Which of the following would be the actual cost? Oh, Jesus Christ. They simply ask you to add the two numbers. What the hell? 5, 3, 8, 5, 9, 1. There you go. 195,835. This is ridiculous. In the previous question, it was so complicated there. So we go from, as the Napoleon had said one time, from the sublime to the ridiculous. It was Napoleon Bonaparte, as far as I know. Again, this quote, from the sublime to the ridiculous. This is ridiculous. That was it. That was the end of our journey. I hope you got something out of it. If you find out that, if you feel that you actually do need help, one-to-one help that is, and if you're looking for a tutor, and if you'd like to work with me, you can call me. There is a phone number here, 1-800-808-PREP, 1-800-808-7737, or you can reach me at my email, preprep, SAT, at AOL.com. Drop me a line, and I'll be more than happy to do what I can to get you ready for the exam. But I had fun, and it was a pleasant journey. Good luck to you on the exam. Okay? Bye now.